everyone! Hopefully, you've had the chance in your lifetime to activate a glow stick. Glow sticks are fairly common and they make use of something called chemiluminescence. Chemiluminescence happens when a chemical reaction occurs, but instead of giving off heat or taking in heat, it actually gives off energy in the form of light. And so it's different from a combustion reaction which would give off heat. It is exothermic though, because there's definitely energy coming out of this thing. And this one is very pretty. It's got this cool yellowish green. Look at that on my hand. That's awesome. It's so satisfying doing that. Today, I'm cooking up a recipe for chemiluminescence using a molecule called 3-amino-phthalhydrazide, or commonly known as luminol. My recipe involves a few ingredients that I just have to dissolve in some water here. By the way, this little thingy here is like the coolest thing ever invented. There's a Teflon coated magnet I put in my beaker, and this hot plate stirring thingy is actually going to make that thing spin, and so I don't have to stir it myself. I could watch this all day, but I'm gonna go ahead and get started with some sodium carbonate. Get that in there. We have a little bit of ammonium bicarbonate. We have some sodium bicarbonate, and all these carbonates and bicarbonates are going to serve to make the solution suitably basic and provide the ions we need. Then we're going to put in a little bit of copper sulfate. The copper ion in here, much like the iron ion in hemoglobin, is going to act as a catalyst for this reaction to occur. Luminol needs a catalyst, and it also needs a basic solution. So we're going to try to provide that here. And once that's all dissolved, that stuff dissolved pretty quickly, I have about 1/3 of a gram of luminol, and that's going to go in. This is going to take a little bit of more time to dissolve, so I'm just going to let it sit here for a little while, and I'm going to walk away and come back in a little bit when it's ready. I'm wearing gloves just because this stuff is kind of toxic and I don't want to get it on my hands. Once the reaction's complete though, the products are harmless and I can just dump that down the drain. But for right now, a little precaution. I think it's ready. Luminol has trouble dissolving in water because it's more of a non-polar type organic molecule. I still see a few chunks laying around, but there should be enough in solution. Luminol solution in here and some hydrogen peroxide in here. Let's go. This one gives off a blue color because the luminol molecules have gone to their excited state during the reaction and now they're coming back down to the ground state, and they give off photons of light around 452 to 489 nanometers, and those are wavelengths of blue color, and so we get this nice pretty blue color out of it. In this reaction, the luminol reacts with hydrogen peroxide in basic solution and with the catalyst, and it gets oxidized. The hydrazide groups become oxygen, these become carboxylic acid anion groups, and they're excited, so we give it a little asterisk, and when it moves down to the ground state, it gives off light. Compare that to my glow sticks, which are giving off photons more in the green and yellowish region of the spectrum. Those would have longer wavelengths than the ones we're seeing from the luminol. All atoms and molecules have what's called a ground state. It's sort of a state of rest where all the electrons are in the lowest energy positions possible. But then when energy is added to the atom or molecule, those electrons can actually move up to higher energy states, which we call excited states. And there's only a limited number of possibilities. Electrons can't just go halfway. They have to go up to specific energy levels within the atom or molecule. But once they're in the excited state, they only stay there for a very, very short period of time before they start coming back down toward the ground state and losing the energy that they just got. And as they lose that energy, they can emit those energies. Let's say this electron goes up, they can emit those energies as photons of light. That energy is being given off, and so in this case you might get a blue photon with a certain wavelength that we can see as blue light. And if we have, for example, a smaller transition, where this one maybe is only giving off a smaller amount of energy, that may correspond to a longer wavelength of light, that in this case we might see as a green photon. And so the energy given off by atoms and molecules is equal to the difference in energies between the ground state and whatever excited state that it's at. Now I'm going to try it in a slightly different way. I've got a different setup here with a funnel on top of this round vessel that has a stem, and it's sitting over the top of this beaker into which I've put some fluorescein. You might have heard of fluorescein. Eye doctors use it as a topical dye to evaluate eye problems. It's also a coloring, FD&C yellow number 7 or yellow number 8, depending on which form it's in. It also, as the name kind of suggests, it fluoresces when you put it under ultraviolet light like I'm doing here. Fluorescence is different from chemiluminescence. Chemiluminescence is when a chemical reaction produces light, whereas fluorescence happens when a molecule absorbs energy of a shorter wavelength or higher energy and emits light of a longer wavelength or lower energy. In this case, it's absorbing the ultraviolet and giving off photons in this yellow-green region of the spectrum. I've got my two solutions again. This time I'm going to drop them into the funnel simultaneously and we'll see what happens. Here we go. Yeah. So we had the original reaction up here that was blue and it gave off chemiluminescent blue light. And then when it dropped into the fluorescein took some of the energy from the reaction and now it's giving off yellow light right around 520 nanometers. Never done that one before today. That was very satisfying. There you have it. A simple recipe for chemiluminescence with a little fluorescence thrown in. If you have any questions, throw them in the comments. In the meantime, happy experimenting and have a great day.